Can fasting boost power, even without exercise training? In this video, we are looking at the article, Time-Restricted Eating Without Exercise Enhances Anaerobic Power and Reduces Body Weight. It was published in Nutrients in 2025 by you and colleagues. The study tested whether time-restricted eating, also called TRE, could change body weight, aerobic endurance, and anaerobic power in healthy untrained adults. The interesting part is this: the participants did not perform structured exercise during the intervention. So this is not a training study, it is a meal timing study. The question is whether changing the eating window can influence performance-related outcomes. Before we continue, make sure to subscribe to Sports Science Insight. Here we break down sports science research into simple, practical, and evidence-based insights for athletes, coaches, students, and practitioners. Let's break it down. Time-restricted eating means that you eat within a specific time window each day. Outside that window, you fast. In this study, the eating window lasted 6 hours. Only water was allowed outside the eating window. The important point is that TRE mainly changes when you eat. It does not automatically prescribe exactly what you eat. Of course, food quality and total calorie intake still matter. But the main strategy here is timing. By extending the daily fasting period, TRE may influence metabolism, insulin sensitivity, fat oxidation, circadian rhythms, and energy availability. So the key idea is simple: TRE changes when you eat, not necessarily what you eat. This study compared two different eating windows. The first was early time-restricted eating, or ETRE. In this condition, participants ate between 8 o'clock and 1400. The second was delayed time-restricted eating, or DTRE. In this condition, participants ate between 12 o'clock and 1800. Both protocols used the same 6-hour eating window, but the timing was different. That difference matters. Eating earlier in the day may align better with circadian rhythms and metabolic control. Eating later, especially closer to the afternoon, may better align with the time of day when neuromuscular performance tends to be higher. So the same fasting strategy may work differently depending on timing. That is exactly what this study wanted to test. This was a randomized crossover trial. That means each participant completed both conditions. The study included 28 healthy university students. They were young adults, not trained athletes, and they were asked not to perform structured exercise during the study period. The full study lasted 10 weeks. Participants completed 4 weeks of one TRE condition. Then they had a 2-week washout period. After that, they crossed over and completed 4 weeks of the other TRE condition. This design is useful because each participant acts as their own comparison. So the study could compare early TRE and delayed TRE within the same group of people. The key point is this: each participant tested both eating schedules. The researchers measured 3 main outcomes. First, body weight. This was measured in a fasted state. Second, aerobic endurance. Participants performed a constant load cycling test until exhaustion. The test used a fixed workload, 150 watts for men and 90 watts for women. Third, anaerobic power. Participants performed 3 all-out 10-second sprint cycling efforts. The highest peak power output was used for analysis. So this study tested both health and performance markers. Body weight tells us about the general effect on mass. Time to exhaustion tells us about endurance. And sprint peak power tells us about short-duration explosive performance. The first major result was body weight. Both eating windows reduced body weight. After early TRE, participants lost about 1.56 kilograms. After delayed TRE, participants lost about 0.61 kilograms. So both protocols moved body weight down. But early TRE produced the larger reduction. This may be because earlier eating windows can reduce evening calorie intake. It may also align better with daily rhythms in digestion, insulin sensitivity, and energy metabolism. But we need to be careful. The study did not directly measure body composition in detail. So we cannot say exactly how much of the weight loss was fat mass, lean mass, or water weight. The correct message is, eating earlier produced the stronger weight effect. The second result was aerobic endurance. Here, the finding was neutral. Time to exhaustion did not significantly change across the phases. So, TRE did not clearly improve aerobic endurance in this study. But it also did not clearly reduce endurance. That is still relevant, because the participants were eating within a restricted window and had lower energy intake, but their endurance performance was maintained. For people worried that TRE might automatically reduce endurance capacity, This study does not support that concern. But we also should not oversell the result. There was no clear aerobic boost. So the message is balanced. TRE did not improve endurance, but it also did not clearly reduce it. The most striking performance result was anaerobic power. Anaerobic power increased after both TRE conditions. After early TRE, peak power increased by about 21.25 watts. After delayed TRE, peak power increased by about 35.43 watts. And the improvement was larger in the delayed TRE condition. This is interesting because there was no structured sprint training, resistance training, or high-intensity exercise intervention. So the study suggests that meal timing may influence short-duration explosive performance, at least in untrained adults. One possible explanation is that delayed TRE may better match the afternoon period, when neuromuscular performance often tends to be higher. It may also provide better energy availability closer to the testing period. The biggest performance signal was anaerobic power, and in this study, delayed TRE produced the stronger improvement. Why might timing matter? The authors discuss several possible mechanisms. First, circadian rhythm. The body does not respond to food the same way at every time of day. Metabolism, hormones, glucose handling, body temperature, and neuromuscular performance all follow daily rhythms. Second, energy availability. If food intake happens closer to the time when high-intensity performance is tested, the body may have more available fuel for short explosive efforts. Third, metabolic flexibility. TRE may support the ability to switch between different energy substrates. Fourth, mitochondrial signaling. Some evidence suggests that fasting and meal timing may influence pathways related to mitochondrial function and energy production. But this is important. These mechanisms are plausible, not fully proven by this study alone. The correct message is, the body may respond differently depending on when fuel arrives. So what should we take from this study? First, time-restricted eating reduced body weight in untrained adults. Second, early TRE produced the larger weight reduction. Third, aerobic endurance stayed stable. Fourth, anaerobic power increased in both conditions. And delayed TRE produced the larger power improvement. So the practical interpretation is goal-based. If the main goal is weight reduction, the early window looked stronger in this study. If the main goal is anaerobic power, the delayed window looked stronger. But this does not mean meal timing replaces training. It does not. Training, nutrition quality, recovery, and consistency remain the foundation. TRE may help, but it is not a substitute for exercise. If this video helped you, leave a like, subscribe to Sports Science Insight, and stay tuned for more evidence-based content on training, recovery, nutrition, and performance. And tell me in the comments, would you choose an early eating window for weight loss, or a delayed eating window for power? See you in the next breakdown.